Good evening, guys. Okay. Okay. Three. So today we are going to discuss about one of the topic of object-oriented programming. Then let me know if you guys want to uh, learn about how to connect a database to your Python code, or you want to learn about file processing in Python, right? So we can discuss any one of that. Either connecting our database, working with a database in Python, or we can discuss about file processing. Right? First of all, we are going to discuss about the polymorphism. Now, see, so we have seen that if we have a function, and inside that function, if we have multiple parameters with default values, some default parameters, right? Mm, and print the values of A, B, C. Okay, right. And see, I'm making a call. This call is valid. This call is valid, and this call is valid. This call is also valid, right? Let me take this as indicative. We have seen this, right? Now, guys, see how this particular function is handling things, right? How this particular function is handling this function call without any arguments, function call with single arguments or multiple arguments like these. Better let's use. Okay. Now observe something. Once the function is created, see, this is a function. This is a function. Okay, display is a function. Function is a block of code. So this block of code also required memory to store, code memory or text memory, right? We have seen in our first session that memory block is divided into several different types of memory: text memory, dynamic memory, stack memory, heap memory, and all other types of memory are there, right? And see, for A, B, and C, these are considered as default arguments and with some values, right? With some values. Now see, I'm This is the first function call. And observe this one. There was a function. Display function is created by the interpreter. That's good. But whenever there is a function call, a separate copy of that function is loaded to the memory. A separate copy of that function is loaded to the memory. Okay. And whatever the required parameters or arguments are there, those arguments are loaded. See, we have not provided any arguments here. So A is pointing to the default value -10, B to -20, C to -30. Now for the third function call, see, there is no return value, so it's returning nothing, right? Return type none. Okay. Now we are calling display 10. Again, the function, a new copy of that function will be loaded to the memory, right? A new copy of that function is loaded to the memory. See, A is having its own value, that is 10, and all other B and C are pointing to the default values. This display which is called by this particular function call at line number 4, it is deleted from the memory, right? Once the execution of a function is completed, once the return value of a function is triggered, then that function, the memory allocated to that function will be deleted, right? After that, we have called the new display function with some values. So there is a new function called display function call. Then again a new display function call and new display function call. So you can consider that this particular this line number 1 into this function, this is a blueprint. This is, you can say that this is the syntax of calling a function, creating a function. Whenever a function call is made, depending on the number of arguments, whenever there is a function call, depending on the number of arguments, the interpreter is creating a similar function, loading a similar function in the memory with the required number of default arguments. For the function call at line number 4, the interpreter will load all the default arguments. Okay. See, interpreter is loading all the default arguments. Now, for the function call at line number 5, interpreter will load only 2 default arguments and 1 argument, and 10 is passed to the first parameter A, right? So parameter and arguments, it's only the same name. Basically, it is known as actual parameters, actual arguments, and all these are same names, right? Just naming convention. So see, what I'm trying to describe here is this particular functions are loaded by the interpreter to the memory. In the memory, whenever there is a function call, and the type of argument that will be loaded, the number of default arguments that should be inside that function, it depends on the number of arguments you are providing during the function call. It is determined by the interpreter, right? No. Now, what is polymorphism? So first of all, Python does not support polymorphism, right? That's why I told you that Python is not a good language to practice OOPS concepts. Python does not support polymorphism. Okay, so what is polymorphism? Let me show you an example of polymorphism in another language. Let's use C++ for that. Okay. See, Python is a dynamically typed language, so there is no need to specifically write the return type of any value or the data type of any parameter. But C++, it's a statically typed language. You have to define the data type, right? So No need to understand each and everything, just try to observe. Function. Now this is a function. This is a function in C++. The name of the function is again same. Okay, the name of the function is again same. If I want to create the same function, if the name of the function will be same in Python C, see, instead of this particular function, this function is overridden. Means what happened in Python, we have created a display function one, this particular display function. But when you have created this display function again, what happens? That new display function will cover your previous one, the last display function, and it will completely cover this particular display function. That's why we are getting an error, because C is not a default argument in this particular display function. C is not a default argument. And see what we are getting, the error is display is missing one required positional argument, that is C, for this particular display call, because we are not providing any value for C. Right? But if I will remove this one, comment out this one, then it's okay, good to go. Right? So this particular structure, writing the same function with same name, but different type of data, different types of parameter. This one is known as function overloading. Function overloading. And it is a type of static polymorphism. There are two types of polymorphism, static polymorphism and dynamic polymorphism. It is a type of static polymorphism. Function overloading is a type of static polymorphism, not supported by Python, but it is supported by other languages like C++ and Java. And it is, you can consider that it is a very powerful concept when working with class and objects. If you have heard about STL or collection framework in Java and STL in C++, so function overloading is intensively used there, right? No, see, so Python does not allow this to writing same function. Okay, but here in C++, you can write same function, and each function, see, this is how two different Python functions will react. Means same Python functions will react. The new function will cover the older one, right? But in C++ or Java, what happens? There is a function will be created with name func. Whatever the name is my function and whatever the name is a function, right? Now what happened? A new function with the same name will be created. Then again, a new function with the same name will be created. Then again, a new function with the same name will be created. And why these? Why these many copies of the same function? See, now here is the catch. This is the reason why Python does not allow function overloading. See, in Python, you can pass any type of variable to A, B, and C, right? Any type of variable, a list. Suppose instead of 10, I will try to pass a list. Now 10 is considered as a list, right? It's okay. We're not getting any error because it's a dynamically typed language. But C++ or Java, they restrict that A should be an integer, B should be an integer only. Now, similarly, the function call is same here, function name and the values. Now, see, let me provide some print statements here. Into function into float function. Another one, float function. Now, see, I'm providing integer values, right? And in the next one, I'm providing an integer and a float value. See, and now if I will execute this code, okay, see what happens for this first function call. For this first function call, this function is called, right? See, we are getting the output as int function, right? Why? Because this function is called executed. For this function call in C++, you have to use small f to define if a number is float or not, or decimal point number is float or not. Okay, so it consider this number as float, this number as integer. So when I am passing an integer and a float, this particular function is called. And see, the name of the function is exactly same. Name of the function is exactly same. Okay, but while passing two different types of value, two different types of argument, the data type of arguments differ, then it is calling two different functions. Now, what is polymorphism? All these different types of function are only known by their name, that is function. The name of the functions are same. The name of the functions are same. So existence of an entity or a message, existence of an entity, a message, a block of code in more than one form is known as polymorphism. This particular function is existing in more than one form. I think three forms, right? In three forms. One form is for integer, one form is for integer float, one form is for float. If we will try to visualize this, okay, yeah. See, the first function with int is called for this particular function called line number 23. Now for line number 24, for line number 24, this particular function is called, right? So this is what known as polymorphism, right? And see, the compiler will decide which function to call for different types of function calls, which function to call for different types of function call, and that is known as, you can say, in this case, function overloading is considered as static binding. Okay, that is the concept of C++, so leave that one. So this is the concept of polymorphism. Okay, existence of a message or a function is more than one form. Now see, Python does not allow us to write multiple forms of a display function. Why? Because we can pass any type of data to this particular variables, A, B, and C. If you want to pass a float, that's okay. No problem with that. You can pass this. right? So there is no need to write a separate similar overloaded function to accept these type of values, right? So that's why Python does not support polymorphism. But polymorphism is one of the pillar concept of OOPS. Now, other topic, let's talk about recursion. Now, what is recursion? A function, a function calling itself is known as recursion. Function calling itself. See, this is a function call. What happen if I will write this function call inside the function itself? So I have a function. Okay. Okay. Now see, this is a function, line number 1, 2, 3. Now what we are trying to do, we are calling this function, right? We are calling this function. Okay, we are calling my function C. My function is called. What this my function will do, it will execute line number 2, print inside function. Now it will again try to execute line number 3. What happened in line number 3? In line number 3 is again trying to execute, line number 3 is again trying to execute the function itself. Okay, the function itself. Now see, again the function is called, again the function is called, again the function is called. Why? Because line number 3 is calling the function itself, right? And it will result in an infinite loop. Okay, it will result in an infinite loop. So recursion means a function calling itself. Okay. Now, to take care of the infinite loop, we have to take care of some basic conditions while creating a recursion. Okay. Suppose one of the very basic example of recursion is printing factorial, factorial of a number. Or for the easier one, let's get to try to print all the numbers from 0 to n. All the numbers from 0 to n. Now see, what I will do, let's take a input. After taking the input, let's call the function. Let's name the function as display temp. Display 0 to n. Right, and pass n to that function. Let's create the function. Define display. We're expecting a parameter, and we will do something inside this one. See guys, in this case we will get an error. And why this error? We cannot call a function before creating a function. See, this function call is there at line number 3 and we are creating the function at line number 5, right? So we will get an error. The interpreter will not know that there is a function existing, right? So we will get an error. The error will be function does not exist. Okay, so always put a function call after you have created the function. Put the function call after you have created the function. Okay. Now inside the display function, what we will do if n is double equal to 0, print n return, otherwise print n minus 1, and then again call the display function n minus 1. Let me, okay guys, let's use the debugger this time. Okay. See, it is asking me to enter a number. Right? Asking me to enter a number. I will enter. Suppose let's take 5. Now guys, observe here, right? Variables. This variable section. One variable n is created. See, we have executed line number 1, and what line number is 1 is doing? It's creating a variable n, and we have passed the value 5, right? So a new variable n is created with value 5. With value 5. Instead of n, let's take the name as x. Okay, stop this one. Okay, let's pass the number 5. The value of n is 5. Inside this function variable, we'll leave it right now. Too long. Now let's, so what line number 10 is doing? See, the flow of control, the interpreter is not going to execute line number 3, 4, 5, 6, 7, 8 because it's a function, right? So the interpreter is not going to call this particular function until unless you have provided a function call for that. Okay, so let's, so line number 10 is calling the particular function. Okay, now display function will be called. See the call stack, right? A display function is called. Whatever number of functions a Python script will call, it will be always displayed on the call stack, right? And all these functions, variables inside these functions, and whatever the code written inside this function will take their memory, will take the space inside the stack memory. Okay, we have discussed different types of memories, right? So these variable x, and if you have created multiple variables like list or whatever these variables will be, all of that will take their memory inside the stack memory. Now see, we are inside display function. The value of x is double equal to 0. So the value of x is 5. Let's watch x. So the value of x is 5. Now what we will do? We will print x minus 1. That will be 4, right? 4 is printed on the screen. Again we will call the display function. Again we will call the display function. This time the value of x, will become 4. Okay. Now we will go to line number 7, print x minus 1, that will be 3. This is our output area. 3. We will again call the display function, with x minus 1. Again, the value of x is 3. And see, there are total of 3 different display functions are running in the stack. Why? Because unless you have completed the execution of a single function, that function is not going to exit from the stack, right? So you have to complete the particular function. Now, again calling the function in line number 8 is not going to exit the function, right? It's going to call that function again. So that's why first we have called the function from line number 10, then line number 8 call that function, then line number 8 call that function. So line number 8 is again and again calling that function. Okay. Now it will print the value 2, then again the value of x will be 2, all these things. After this, see, the value of x is 0. The value of x is 0. In this case, in line number 4, the condition if x double equal to 0 will be true. Right? If x double equal to 0 will be true. Now from, see, the if condition is true, so like line number 5 will be going to be executed, print x. It is going to print 0, right? And see, in line number 6, there is a return statement, and observe this stack, call stack. Whenever a function encounters a return statement, it will exit the call stack. This particular function will end there. 6 ratio 1, this function will end there. See, see that 6 ratio 1 function will be deleted from the call stack. Why? Because the execution of that function was completed. Right? Now, after this, we come back to the previous function. See what happens right now. This is my function. Okay. And after executing few lines of code, what happened? There is a recursive function call. There is a recursive function call. And this function, this recursive function call is again calling the function itself. So it will again load the memory to the new function. Means the same function is loaded in the memory again. That same function will, and then again this same function will start executing. Then again there is a function call. This will again call that particular function, and new function will be loaded in the memory, right? So this loading of new function, function 1, function 2, and function 3, all of these are taking memory inside the stack memory. And see, this is the stack, right? These many display functions are called one by one. Now, what happens whenever execution of a display function or any function will be completed and the return statement will be encountered or the body of that function will be completed, what happens? The flow of control, the interpreter will go back to the line, exact same line where the function, from where the function was called. See, this line number 8. This line number 8 called that display function. This line number 8 is calling the recursive display function. Whenever a function will complete from this call stack, flow of control will come back to this line number 8. See, flow of control is again and again coming back to line number 8 only. Now see, it will come back to line number 8, then it will again come back to this line number 8. Now, after the completion of this first function, whenever the execution of this first function will be completed, the flow of control will go back to the initial function call, the first function call. See, there are two display functions. The second display function was called by line number 8. Now, this first display function was called by this line number 10, right? So what happened? It will go back to line number 10. The flow of control from one function to another function will again go back to line number 10, right? So recursion is not a very easy topic to understand, but you can give it a try. Okay. Now, for creating a recursion, or for whenever you are trying to design a recursion, there are two cases. Okay. This case from where the recursion exit, right, from where it is said that the recursion is completed. See, this particular function can again call a new function in the recursion, right, in the recursion line. If we will not provide any restricting value, if we will not provide any boundary value, then this calling of function will goes on, right? There is no stopping. Okay, the execution of function will be never completed. It will go to a move towards an infinite loop, right? So we will provide, whenever we are creating a recursion, we will always provide a base condition. This particular condition is known as base condition. Base condition means whenever that condition is met, whenever that condition is fulfilled, the function will start returning from that point. Function will start returning from that point. So the first thing we require is a base condition. Okay. No. Second thing we require is a general case. This line number 7, this line number 7 is known as general case. What is a general case? General case is the repetitive work which a function will repeat again and again. Whenever there is a function call, the body inside the function, different lines inside the function will be executed, right? So what is line number 7? What are those body that will be again and again executed? Those are known as general case, right? Body of that function. Line number 8. Line number 8 is known as recursive call. Line number 8 is calling the function again. So line number 8 is known as recursive call. Okay. Let's take the example. So whenever writing a recursion, take care of the base case, general case, and recursive call. Okay. We have seen, so printing a Fibonacci series, or let's say printing a factorial, is one of the best example to understand recursion. Right? Now, what is a factorial? So factorial of a number, factorial of 10, or let's say factorial of 5 is considered as 5 into 4 into 3 to 2 into 1. First of all, what is the general case in this particular equation or calculation of factorial? The general case is a number n, a number n is always multiplied by a number n minus 1. That is the factorial only, right? If you try to write the general case for this one, for factor n, is n into n minus 1 into n minus 2 into n minus 3 and so on. You can generalize it further by saying that factorial of n is nothing but n into factorial of n minus 1. and we are going to use this general form, right, to calculate the factorial in recursive manner. We have figured out the general form, right? Now let's get the base. What is the base of our recursion, right? You see, whenever we have encountered 1 or whenever we will encounter 0, so the factorial of 0 is 1. So whenever we will encounter 1, we have to stop there, right? After that, it is nothing like we have to multiply it by 0, then minus 1, and then minus 2. No, right? Whenever we will encounter 1, we have to stop there, right? So what is our general case? Whenever you will encounter 1, stop the function recursion and return from there, right? And return from there. Okay. So let's try to create the factorial. First of all, define factorial. We have a number n. What is our base case? If n is double equal to 0 or n is, okay, this is not the or n is double equal to 1, return 1, right? This is a recursive call in which we are not uh, expecting any value, right? The return statement is only there, it's not returning any particular value, right? Because we are printing the value inside the function only, so it's not returning any value. But factorial is returning some value, right? So factorial recursion is designed to return the factorial of a number, right? If you see it, it is somewhat similar to, if you want to define an add function for a and b, what we do, we return a plus b, right? So it's somewhat similar to, if you are trying to calculate the factorial of a number n, you have to return that factorial, right? So suppose if n is 0 or 1, if n is 0 or 1, this factorial function will return 1 as the answer, because factorial of 0 is 1 and factorial of 1 is 1. That's good. Now else, otherwise, if n is not equal to 0 or n is not equal to 1, what we are doing? What is the general case? The general case is factorial of n is considered as n into factorial of n minus 1. N into factorial of n minus 1. So what we will do, we will return the general case n into factorial of n minus 1. And if you will try to print factorial of 5, and that will be 120, that's correct. Now guys, okay, let's observe this factorial recursion once. Okay, let's use the Python tutor. See, first of all, a factorial function is created. The first call for factorial function will pass 5 to this n, 5 to this n. Now see, the first value of n is 5, right? Line number 2 is false, so we will directly jump to line number 5. What line number 5 is trying to do? Line number 5 is trying to return the value of n, that is 5. 5 multiplied by, again making a factorial call. It is again making a factorial call. See, from line number 5, again a factorial call is made, again calling the function factorial, right? And this time it is passing n minus 1. This time it is passing n minus 1. See, the formula of calculating a factorial of n is n into n minus 1, right? Then n minus 2, n minus 3. So minus 1 goes on, right? Okay. Now, see, for the value of n equal to 4, again the line number 2, the if condition is false, it will again go to line number 5. It will again go to line number 5, right? In line number 5, what we will see, the value of n for this function is 4, right? The value of n for this function is 4. But then again, it will make a factorial call to that particular function with value n minus 1, that will be 3. Then again, there, see, it is again building up a stack of function call. This is the stack of function call. And for each and every function, there is a separate n with its own value. Separate n with its own value. And these functions are not deleted. These previous functions are not deleted yet because the function execution is not completed. Line number 5 is again and again encountering, means calling the function. So return statement is not yet encountered. Line number 2, again n is 3. Then line number 5, again factorial call with, and the value of n as 2. And number 2, again the value will be false. Again the factorial call with n, that will be 1. And line number 2, this time the condition is true. So we are going to encounter line number 3. Now see guys, this last factorial call, this second last factorial call has called this last factorial function with n1, right? Okay, so in this case, what is going to happen? This return one value. Okay, let's create a diagram for this one. Okay, so this is our function, and we get the value of n as 5, right? This function made a recursive call to the similar function with value by reducing a value to 4, right? Now, this function will again call a recursive function by reducing the value to 3. See, we are reducing the value by n minus 1 each and by calling each and every recursive call. Now, again, this function will call the same function with the value 2. Again, this function will call the same function with the value 1. Now guys, when the value 1 is encountered, when the value of n is 1, there is a return statement, that is return 1. So what happened? When we encounter this particular function, what happened? This function, this function will return a value 1 to its previous function, the function from where this function is called, a value 1. Okay. See, now this particular line has called that function, right? The linear function. Okay, so if we have, okay, Okay, we are in this condition when the value of n is 1. When the value of n is 1. And line number 3, it is going to return 1, right? It is going to return 1. This 1 will be returned to line number 5 of just the previous function where the function call is made. See, the function call is made from line number 5. So this factorial function will come back to this previous factorial function in line number 5. Okay. So what happened? We encounter the return statement. In line number 3, we encounter the return statement, and we will go back to line number 5 of the just the previous function from where this function call is made, right? From where this function call is made, we will go back to that function. We will go back to see. We come back to the previous function. That function is deleted from the call stack because the execution of that particular function with n equal to 1 was completed. Now, focus here. The current value of n is 2 and the value returned from the previous function is 1. See, the current value of the n is 2 and the value returned from the previous function is 1, right? And where we are standing in line number 5 right now. And this particular line, this factorial n minus 1 call is replaced by 1. Okay, why? Because that particular factorial n minus 1 call is returning 1. So now what happened? This particular function, the current function in which we are right now, the current function, this function will return the value of n multiplied by the factorial, whatever the result we will get. So the result we have is 1. The value of n is 2. So this particular function will return 2 into 1, that will be 2 to the its previous function, to this function, its previous function. See, that function is deleted from the memory. Now the control come back to the previous function and the factorial has returned 2. See, we are, so what we have in hand, 2 multiplied by 1, and the multiplication result will be returned to the previous function as 2. Why? Because this function, this function with the value 3, this third function has called this particular function, right? So once the execution of this function is completed, then it will go back to the previous function from where it is called. And the value is 2. So value is 2. Then again the value of n is 3 in this case. Then again we will multiply, and then again we will send this value, return this value back to the previous function, value 6. So value 6 is returned to the previous function. Then again the value of n is 4 in this case. So this 24 will be returned here. Again the value of n is 5 in this case, in this particular function. So multiplied by 24, that will be 120, and 120 will be returned to the first ever function call that is made. First function call that is made from line number 7, it will return to that with the value 120. Now guys, whenever there is a function call, whenever there is a return call, whenever a function returns something, the function will delete from the stack. Function will delete from the stack. This function had returned 2, this function will delete from the stack, right? See, the value of that 2 function is deleted. Now we are standing in this particular function, right? With the value of, yeah, with the value of factorial as 2, returning value of factorial as 2, and the value of n is 3. Again 3 multiplied by 2, that will be 6. So this line number 5 from this factorial function will send that, return that 6 back to this previous factorial function. Okay, now see, factorial is returning 6 to the previous function. So factorial, this one is returning 6 to the previous function, and once this was returning of value, this function will be deleted from the stack. How many functions do we have in stack? Two functions. See, we have two factorial functions in the stack. All other functions are deleted after returning the value, right? Okay. No, 4 is there. It will again return 24 to the next. See, it is returning 24 to the next function, so this one will be deleted. Now we have only one function in the call stack. After multiplying this particular value, 120 will be returned to this factorial function call. See, the factorial function call is returning 120. That will be printed on the screen, right? So yes, it is a little bit complicated to understand recursion, but it's one of the important topics, right? If we are talking about functions. Okay. So now guys, let's talk about pip. So open the command prompt and pip. So pip is the package manager for Python. Whenever you are creating a large project, a real life project, you will need multiple packages. For example, we have seen math, right? We have seen the module of math module with a different function. But sometimes you may need some extra packages to working while working with different types of projects, right? Suppose in case you want to connect to a database, in case you want to connect to a database and to run multiple SQL query, right? That is your requirement. Connect to a database and run SQL queries, right? For that case, how to connect to a database while using Python? Okay. Consider this as your Python code. Okay. And I am assuming that you have a database installed in your system, any database, Oracle, SQL Server, uh, MySQL or Postgres. I am using Postgres. Okay. To connect your Python code to the database, you need a connector, you need a bridge. Okay, you need a bridge, and you have to install that bridge, right? What is the work of this bridge? See, we write Python in symbol and different SQL codes in Python, right? Select statement, insertion statement, create table statement. We write all these in Python code, right? So what this bridge will do, it will take those Python calls, Python commands, and it will convert that Python command to the SQL command for that database, right? So a bridge is used to connect your database with the Python script. Now, if you are using Oracle, then you have to install different bridge. If you are using MySQL, you have to install different one. And if you are using uh, Postgres, then you have to install different one, right? Suppose Oracle connector for Python. See, you have to install Oracle DB to connect to Oracle, right? And in my case, I have to install PsychoPG2. Okay, so to install any package, any Python package in your system, use the command prompt, use the command pip install PG2. Spelling is wrong, you will get an error. Okay. Right. So it will install the package for you in the correct location, right? It is nothing like that. You are installing, downloading a movie, and it will be, and you will leave that movie in your download folder. These particular packages will be installed in a specific folder in C drive. So you always have to use pip to install any connector or any type of module you will need with Python. Okay, so I've installed the connector. No. Plus, you have to basically follow a specific syntax to connect to your database. Right. Now, first of all, we have installed the module just right now, right? So import that module. Import like PG2. Okay. Now see, there are two things whenever you are connecting to a database using a bridge, there are two things. First one is the connection. Consider this line, this arrow as the connection. And there is one more thing, a cursor. A cursor made by this particular connector, the bridge, a cursor. Cursor is responsible for writing a SQL query in the database from a Python script to the database. It is responsible for writing or receiving queries, receiving results or writing queries, right? And first of all, you have to establish a connection. After establishing a connection, you have to create a cursor. Now, for connecting your Python script to a particular database, you have to pass the database name. In my case, it is the use string, Postgres, user, Postgres, password. Okay. So these are the configuration for connecting to my particular database. Okay. Uh, while you are installing a database in your system like Oracle or MySQL Server or Postgres, you will come across these particular settings, these particular default values, right? Port number, host. Okay, in case of host, always write localhost because we are not going to connect to any live server over the internet. We are going to connect to in our system only because that particular database is inside our system. That's why we are using localhost. Otherwise, you have set up a password, you have a username, you have a database name. All these things will be there, right? Okay, let's execute this. I think I have to see. I'm getting a error because I have provided the wrong password. I think the password is correct. Password is correct. Okay. Yeah. So connection is established, right? It is executed and connection is established. If I will try to print connection, see, there is no meaning of printing a connection. It will just print a object of connection class. Connection is itself is connect is itself a function defined inside defined inside the module we have just installed. Okay. No, we have created a connection, right? We have established a connection. Now we have to create a cursor. Now this cursor is always given you by the connection. See, this is our connection object or connection instance. We have just established the connection. This variable con is holding the connection. This is the connection object for us, right? This is establishing the connection with the database and our Python script. Now this connection is responsible for creating a cursor. You have to call a connection function. Consider this connection as just a simple object. We have seen objects, right? Class and objects. See, we have seen class and objects. And to call any function related to an object, what we do, we use a function call. What we do, we use object dot function name, right? Similarly, to create a cursor, you have to call the cursor function from the connection object. You have to call the cursor function from the connection object, and this cursor function will create a cursor for you. Now a cursor is created. A cursor is there. A cursor is created. Now see query. Okay. So a this query is nothing but simple a string in Python, right? And first of all, let's create a table. Let's try to create a table. Create table test one. Okay. And see, this is a SQL query, right? Create, select, insert, all those are SQL queries. Create table test. Let's take something. Okay. So what I'm trying to do, I'm trying to create a table. So we have a query. We have established the connection. We have a cursor. First thing, establish the connection. Second thing, create a cursor. Third, prepare a query. Now it's time to execute this query. Right? It's time to execute this query. Delete that one. Cursor.execute and pass the query. Now what this cursor will do, this cursor will execute this query in the database. Now with the help of this Python script, we have created a data or table named as, what is the name of the table? Test1, which is related to Postgres, right? Okay. Okay, I have provided the wrong database name. Take care of that. Databases. Let's use. Okay, let's rename this to example. We have to do connection.cursor.execute. It's cursor.execute. We are not getting the input. Cursor will execute the query. We created the cursor. We have the query. Table test only. Document. Let's access a result. Try to access a result. Okay. Let's connect to some other one. Test one. In this one, I have multiple tables. Let's try to extract from loan table. Okay, so the database name is test one. Our new query will be okay. select asterisk from loan. Execute query. Okay, it's executing. We are not getting any error. See, this particular query. This particular query is returning some result. Right. This query is returning some result. And whenever there is a query which is returning some result, in that case, what we'll do? Let's store that result. Okay, and let's try to print that result. Okay, we are getting none. Do I have data there or not? Okay, we have some data there, and this particular data is in the form of a tuple. Okay, stuff all for item and result, print item. Okay, now it's good. See, inside this particular loan table, I have some data. And while executing this particular query from a Python script, we are getting all the data. See, whenever you will execute a query which is returning some result, right? Select statement, and yeah, select statements are returning some result. So whenever you are running some query which is returning some result, select statement, delete, insert also returns a particular value, right? That value will be the number of rows that is inserted. Delete will also return a particular integer value, which is the number of rows that will be deleted, that is deleted, right? Now select will return a result. That result is stored inside the cursor. That result is stored inside the cursor. You have to use fetch all function from the cursor to get the result. Fetch all is used to get the result. Okay. Instead of fetch all, if we will do this indexing 0, see what it is doing. Okay. First of all, okay. See, the first line, this particular first line. Okay. This first line is storing some data. 3, 3. Okay. Right now, ignore these value, decimal and date dot date time. These are just describing the data type of the values, right? Data type of the values, date dot date time, decimal. These are only just describing the data type of the values. The values are 3, 3, some number, floating point number, some date and date, right? If you only want to access a specific value, you don't want to fetch all the result, you only want to access a specific value, what we'll do, instead of using fetch all, what we will do, we will do fetch all, and we will only take the particular index. See, all this data inside the fetch all, inside this result, is stored in a particular index. First line in index 0, second line in index 1, third line in index 2, similar to a list. The result, the fetch all, means the result returned from a query, a select query, is always a list of tuples. It is always a list of tuples. Okay. Now, if I'm only accessing 0, index 0, it means I'm only accessing the first element of the list. The first element of the list. and these are the values of the first element of the list because we are using for loop for that. Let's first of all directly print result. Okay, and here in this case it is just printing using for loop, that's it. If you will use type with the result, see what we will get. It is a class tuple. In this case, because we are using the first index, if I will remove this one, it will be a class list and list of tuples, right? So there are two cases. In two ways you will get this. And this indexing. Okay, we have seen select statement and okay, leave the insert for now. See, suppose you are trying to, suppose I'm asking the user to enter a particular ID to search in the database, right? Something like this, ID equal to, okay, first of all, do I have ID column in loan table? It's loan ID. So loan ID equal to int input enter the loan ID search. Let's prepare the query. Query will be select asterisk from loan where ID equal to its loan ID. Okay. Do I have other columns? Loan ID, date, and all this. Let's take then this one. To execute this type of query where you are passing some values inside the query by during runtime by taking the value from the user. See, I'm taking this loan ID from the user and I am trying to pass that loan ID here, right? So how we will execute that query? We will use cursor dot execute query, and with the query we will pass a tuple. Always remember it is a tuple. So we will pass loan ID, and as it is a tuple, so we have discussed that whenever we are storing only one value inside a tuple, we have to provide a comma, right? Now this loan ID will be transferred to this percent %d during the query, right? Okay, first of all let's check if it's working or not. So unsupported format character D. L is not working. I. Okay, so it's working, right? Use percent %s. See, these percent %s are different types of data type modifiers, right? For integer, for strings, for double, for float. For each and every data type, there are different types of modifiers for that, for different types of literals for that. Modulo S, modulo, there is modulo L, modulo P. I think there is one modulo UX also. Now, see, this cursor is executing the query. Now, we know that inside this loan table, there will be only one person with the loan ID, right? With this particular loan ID, there will be only one person. So whenever we know that result is storing only one tuple, only one row, in that case, we can use cursor dot fetch one, and okay, equal to, let's print result. See, this particular person is with loan ID 10, some other amount 10, and all these. We have a person with loan ID 10 and all the details, right? Instead of just printing the result like this, we can use the for loop. So we can use the for loop. So person with ID 9 and all the values are here, right? Fetch 1. In this case, if I will use only indexing, right? The indexing we have seen, if I will use this will only extract this 9, this 9. Let's see. We are only getting the 9, right? If we will completely print the result, so result is a tuple, not a list. While using fetch one, result is a tuple, not a list. Okay, and tuple with different values. And if I'm trying to access index 0, index 1, we will get the specific value only. Okay, while using fetch all, we are getting the list of tuples. While using fetch one, we are getting only a tuple, right? So these are few uh, methods while working with the database. If you want to execute transactional queries, transaction queries like commit, rollback, and all those, so you have to set the auto commit to false. So dot set it's with the connection then. We have auto commit function with this one also. Auto commit, auto commit. Okay, it's connection dot auto commit to false. So it will not going to save the particular file on its own. You have to commit that one, right? You have to use connection dot commit to commit the changes. These are used for transactional queries, right? Connection dot rollback to change to roll back any changes. Suppose one of the robust way of using connection or executing SQL queries is by with the help of try catch block. That is, in this case, is try except block. That is exception handling in Python, right? Exception handling. What is exception handling? Whenever there is an error, for example, a is equal to 8 divided by 0, it will throw an error, right? Zero division error. But if I will put it inside try except block, a is equal to 8 divided by 0, we are not getting any error, right? Why? See, we are getting an error. This particular line is not executing, right? So it is the role of try except block is that see, whenever you're thinking that this particular line of code or this particular script is going to throw an error, is going to face some error, in that case, we will write that script inside try block. If anything happens inside the try block, right, if any error arises inside the try block, the interpreter will directly execute the except block. It is somewhat similar to if else. If the condition is true, if block will execute. If the condition is false, else block will be executed. In try except block, if there is no error, then try block will be executed. If there is any error, then except block will be executed. Except block will be executed, right? Now see, so first of all, we are trying to establish a connection here, connection with the database, right? So always try to connect with the database and whatever these things inside the try block. Always try to create the function inside a try block. Inside the except block, write print connection failed. Okay, and let's use some e. Now we are getting is not defined. Okay, let's provide some different password. Okay, comment out these. See, we are trying to execute a connection, right? Let me remove all this. Let's create it. So query block. Okay, this is the connection block. See, we are trying to connect to the database, but the password is wrong. If I will execute it without the try except block, we will get an error, right? But while using the try except block, whenever you will face an error inside the try block, the except block will be executed. The except block will be executed, right? And the exception will be, let's not use exception, let's use it's not creating the object. And then in this case, different methods with exceptions, arguments. Okay, leave this one then. Okay. Now the case is we are expecting some errors, right? Now, whenever there is an error, and suppose you are writing a query to insert some values, insert some data. For example, I'm writing some query to insert some values. Insert into loan values will be format is loan ID amount date. I think I have implemented the foreign key and primary key in this case. Okay, 2 is not there. Let's try to insert 2. Amount 3000. Date will be format for that year, month, day. Okay. So our requirement is to insert this value, right? Okay. We have to insert this value, but the condition of inserting this value is that we first have to check. We first have to check that there is no value with this particular ID 2, right? So select asterisk from loan where loan ID is equal to percent is equal to 2. If there will be no loan ID with 2 inside our table, what we will get when we will use fetch all or fetch 1, we will get none, an empty list or an empty tuple, right? So our requirement is to execute this query first, then after that execute this query, right? If this particular query is correct, then only execute this query, right? See, so there is a sequence. We have to execute one query after another, and the sequence depends upon the condition that the first query should be executed. In such cases where your output or your requirement is that you have to complete a set of transactions, you have to complete a set of queries. In this case, this particular query, after that we have to execute this particular query. In those cases, you have to set the auto commit to false. You have to set the auto commit to false. I think I've created the cursor. Okay. Now, remove these. Use try catch. Sorry, try except. Now, inside try block, we will execute these queries. First of all, we will execute this query. Cursor execute query result fetch cursor dot fetch one. If length of result is 0, in that case, we will execute this query. That will be cursor dot execute query. To this we will execute the query and this query will be inserted, right? See, and whenever if we will encounter any error, if we will encounter any error in between while executing any of the queries, what we'll do, we will roll back each and every transaction, right? Because the auto commit is false, it is not going to save automatically. So we will roll back everything. Connection dot rollback. Okay. Now, so and finally, now finally is a block. Finally is a block which will be executed in each and every case, right? Each and every case means if you will encounter, if the code will encounter an exception, then except block will be executed. Then after except block, finally block will be executed. If there will be no exception in the try block, then try block will be executed. Then after that, finally block will be executed. After that, finally block will be executed. No. So finally block will be executed in each and every case. Let's print here. Print that execution completed. Execution failed. And then here, see, whenever you have opened a connection with the database and you have created a cursor, after completing the execution and queries, you have to close these connections, right? You have to close these connections, right? For closing, so in each and every case, if the transaction failed, in that case also you have to close the connection. If the transaction is completed, then also in that case you have to close the connection. For closing a connection, we use connection dot close and cursor dot. So first of all, you have to close the cursor. Then after that, you have to close the connection. Okay, and print connection closed. Now let's execute. First of all, this one. Okay, HP. We have just put it inside the try block only, so we won't get any case. Okay, connection failed. That's good. So we have to create the password. Let's go print here. Connection completed with auto commit false. See, connection completed with auto commit false. Now we will try to execute these queries, right? And see the output. Execution failed, connection closed, and we have an error in this case. Execute query, fetch one, set ST from node ID to syntax for date is also okay. Okay, so the execution failed, right? Execution failed. If the execution failed, see, there is the data is not inserted here. There is no value, no loan ID with the value 2, 3, 6, 8, 9, 10, 4, 1. There is no loan ID with value 2, right? That's why we are using auto commit as false. And inside this, finally, use cursor dot connection dot commit. Okay, the error will be. See, I'm getting the error cursor already closed because this particular finally block is executed and the cursor is closed, right? So I have to execute this particular code block again to establish the connection, to open the cursor and the connection again. Again, execution failed. I think there is some error. Let's see which one is failing. Select. Okay, so the result is none. Instead of 0, we have to compare with none. Not good to go. Then again, execution failed. Getting some primary constant is inserted. Okay, we cannot calculate the length of the result because result is none. So if not result, not result. Cannot calculate the length of a none object, right? So execution completed, connection closed. Now let's see if the execution is completed or not. See, a new tuple, a new row with some value 2 is inserted, right? And if I will forgot to do commit, okay, see, auto commit is false. And if I will forgot to do commit, let me delete that one. I forgot to do commit. Execution completed, connection closed. See, the value 2 is not saved inside my database. The execution is completed. That particular query is executed, right? There is no error in executing this particular query. But connection dot commit, we have not committed our connection. We have not committed our transaction. So in such cases, for example, in a transaction, bank transaction, you have to implement try except blocks, finally block, to take care of these types of scenarios where you have to set the auto commit as false and you have to manually commit or manually do rollbacks, right? Always remember to close the connection and to close the cursor. First of all, first close the cursor and after that close the connection. Okay. So guys, if you have any doubts, then let me know, or we will end the session. Okay, so we have seen polymorphism, recursion. Python does not support polymorphism. Right. Okay, about these types of queries, right? About such type of queries. Okay, remove this one. So once the connection is closed, then again you have to create the connection. So I'm not closing the connection right now. Let's remove this finally block from here. What I'm trying to do, let's run one more query to search a particular element. Select asterisk from loan, where loan ID equal to percent %s, comma, with one more column, account ID to percent %s. See, in this time we have two parameters. We have to pass two parameters. Okay, except cursor dot execute query. Okay, it is not necessary to name this string as a query, right? It is just a convention. You can name it anything, right? You just have to pass that string. After that, pass the values which will be replaced by this percent %s, and the values will be replaced in sequence. First of all, if I'm passing, see, the loan ID is 1 and account ID is 11. I'll be passing 1 comma 11. So this 1 will go for loan ID, this percent %s, this 11 will go for this particular percent %s. Okay, semicolon. Now let's fetch the data, the result we have, result, and we know we will get in only one output, so fetch 1. Print result, otherwise print execution failed. And there is no need for rollback because we are not inserting anything, or you can apply loom back, rollback for that. Connection established, connection completed, execution failed. For this one, the execution failed. Account ID, right? Account ID, loan ID, query 1 and 11. It's not comma, it's and it is a SQL command. Okay, so we will get some output. So this is how you can provide. So you can provide n number of parameters, right? While you creating a SQL command. Okay. And yes, after this one, let's use finally, and we'll do close the connection. First of all, close the connection of the cursor. Then close the connection. So execution ended and the connections are closed. Okay guys, then let's end the session.